Okay, so hello class. Today we're gonna build some parts of this Super Nintendo controller. This was originally a tutorial made by Ricardo Roberts, and it's a very good tutorial because it will give you all the tools you need to build your robot, your final project. And throughout these next 5 classes, we're gonna build different parts of this controller, and then we will going to assemble it. So let's start. Create file, new, and click on part. Before actually building the controller, I'm gonna show you just some stuff that can help you understand uh, some aspects of SolidWorks. So let's just create. I'm gonna create here a rectangle, center rectangle, and as you can see, all the lines in this rectangle are blue lines, which means they are underdefined. You can see also here. When I start putting some dimensions, for example here, if I put 50, then you will see that some of these lines turn black, which means they are defined. And you can see these lines are not defined. The reason for this is that, for example, when I created this rectangle, I said, okay, this rectangle should be centered at the origin. So that's already one relation. But then I specify this dimension, and I said, okay, this line, the length should be 50. So what this makes is that these lines, these parallel lines, these and these lines, they are all defined. Like for example, we know that they are 50 millimeters away from each other, and due to the first relation, we know they are 25 millimeter away from each other. So there is no other way this line could exist in this drawing. Okay. The problem with this, the difference is that these lines, for example, could be closer to the origin or could be far away from the origin because we haven't specified the height of this line, the length of this line. So that's why they are underdefined, because there are many different options for them to exist. So right now we specify and we just put like 30. And now this rectangle is fully defined, and there's only one way it could exist given these relations, like the 50 from this length and the 30 from this length, and that it was created at the origin. So why is this important? It's important because when you're creating more and more complex drawings and you start putting more and more relations between each other, things can get complicated and things can get crazy. Like maybe you want to put some relation and then SolidWorks draws it like in other different way because uh, there were other type of options. It was ambiguous. So I will show it to you later, but it's very important that when you are creating something very complex, that all your shapes start to be fully defined before you go to build other type of shapes. Okay, so right now I'm just delete this, and I will start with the drawing. So first, let's draw 2 circles here and here, let's say. So now I'm going to tell SolidWorks that this circle, the center of this circle, should be at the origin. So I'm gonna select this and this using the shift button, and I will select coincident. Now I want these circles to be horizontal to each other. So I'm gonna select this point, I'm gonna select this point, and select horizontal, as simple as that. Then I want to select, I want these circles to be from equal size. So I'm gonna select this circle, I'm gonna select this circle, and select equal. Now, I'm gonna select the size of the circle. I'm gonna tell it to be 62 millimeters of diameter. Wow, as you can see, there was a mistake here because I didn't define it correctly. So this is a very correct is drawing according to SolidWorks because it accomplishes all the relations you see. Like these two circles are horizontal to each other. They all have 62 millimeters of diameter, and so yeah, they're good for SolidWorks, but they're not good for us because we made a mistake before, and that's why it's very important to define the relations to fully define an object before. So we're gonna click Control C, and before increasing the size of the circle, we're gonna first define what should be the distance from here to here. So the distance should be 82 millimeters. So now that they are far away, I'm gonna say, okay, I want it to be 62 millimeters. Oh, okay. Now both circles are fully defined. Next step, I'm gonna draw a line here. See that when I'm drawing a line, there's a rhomb here, an orange rhomb. When I'm selecting this side, it's creating a relation. Here's the upper part of the circle, and I'm telling it, okay, the line should start coincident to this circle. So I'm gonna click here, and then I'm gonna click here at the upper part of the circle. As you can see, there are more relations created, so it's coincident, but it's also tangent to this circle. I'm gonna show you why. So I'm gonna click OK, and then if you click this line, you will see all the existing relations it has. So it's horizontal because it was the way I created it, and it's also tangent 10, and this is the tangent. So the line is tangent to this circle, and considering these relations, there's only one way it could exist, so that's why it's fully defined. So right now we're creating, okay, we already have this side. Thanks to Ricardo, we already have these measurements and the geometry that could help us build it. So right now we're going to create these circles that will help us give the curvature to the controller. So right now we're going to use the circle tool, click here, and choose this circle to touch this big circle, and that's how we make a coincident relation already. We'll need to specify it later, and we do the same here, coincident. Okay, then we want these circles to be equally with equal size, so we select both and we select equal. Then we want them to be at the same height, so, and we want a line between them, so we create a line. Start here at the top of the circle, remember the orange shape, and here you can see there's a slope here, so it's not horizontal. So what we need to do is to click here and then click horizontal, and okay, it's not yet fully defined. So what we need to do right now is to find the diameter, in this case 10 millimeters. Okay, So right now they are not fully defined yet because this line could be higher or this line could be lower. So let's just put this and this and tell SolidWorks for this distance to be 24 millimeters. So now we have fully defined circles and a line below. So next step, we're gonna create the space for this button. So let's go back. To create this button, we need two rectangles. Using the center rectangle, we click center, and here click escape. Okay, no, not smart dimension. Center rectangle again, and we need to create another rectangle here. Okay, and smart dimension. Click this measurement. It should be 8.7 millimeters. 8.7. And this line should be 25 millimeters. 25 millimeters. And to make things simpler, to put as less dimension as possible and more relations, let's just put this, select this, and select equal. Okay, and then select this and select this and equal. So now we have two rectangles that are equal. So in case we need to modify the length of this, we just modify this, and the other one will modify automatically. So then we will need to move to this side. We see a drawing. There are 4 buttons. These 2 buttons, these 2, are the same distance from the center of this big circle, and these 2 buttons are the same distance from the center of this. So let's do this. Create a circle here. Here's the guidelines. Here's the center of the circle. So I will create it here. So now I will dimension it. I will put it 11 millimeters. And I will choose the distance from here to the center to be 11 millimeters. Okay. You can see it's still underdefined. The reason for this is that this circle can be 11 millimeters in diameter, 11 millimeters away from the center, but it can be at any position from here. It can rotate, right? So what we need to define it is to select this point and select this point and tell SolidWorks that we want them to be vertical, which means that they will be in the vertical line, the same vertical line. So we select vertical, and that's all. Now, to make the other circle that is at the same distance, we will take advantage of the symmetry, and we will use a tool called mirror. So before that, we're gonna create a central line just to specify the axis of the mirror, and then we will click here, mirror entities, and select the entities to mirror, which is this circle, and select mirror about this axis. And as you can see, it created the mirror of this circle through this axis to this side. Okay, fully defined because this one is fully defined. So right now we're going to build the other circle. It has the same size. So what we're going to do is to click here and to click here until SolidWorks they are equal. And now the thing with this is that they are at a different length from the center. So we're gonna click here, and we will choose 14 in this case. As you can see, it's underdefined because from the same problem as before. So we need to select this point and we need to select this point and tell it to be horizontal, not vertical, horizontal in this case. And now we have it fully defined. Now we use also the mirror tool. So we create first the axis and then mirror, select the entities and the axis. And that's all. Okay. So now we have these buttons. What we need to do is to build the holes for these buttons right here. So they're a little bit more difficult. So right now we're gonna use this tool, 3-point corner rectangle. So as the name said, we're creating a rectangle with 3 points. So for this rectangle, we'll need to specify the first point to be coincident with this big circle. So we click here, then we click wherever, doesn't matter, like around here, and then around here. So right now, I'm going to specify the dimension of the rectangle, which is 12. And here, it's 5. Look at this. Be careful, because there's a different dimension here than it's here. So be sure to be selecting this dimension from the side of the rectangle. And you need to put 5. Okay. Now, since the bottom, they have like an arc here, we need to create, well, before that, I still need to define this. So before, I need to tell here in SolidWorks that I want this point and this point to be horizontal. So I click here, and I click here, and I click horizontal. As you can see, it's still underdefined because this point can be here, this could be the size, but this piece can rotate. We haven't defined the angle, the slope of this rectangle. So what we need to do here is to click Smart Dimension, click this line and this line, and it will tell us the angle between these two lines. And we choose 45 degrees. And okay, as you can see, it's now fully defined because I have specified. It can move once I specify these dimensions. So right now, to create this arc, this curvature in the bottom, I choose this tool, 3-point arc. So I'm gonna click here because I'm gonna start the arc here. I'm gonna click here because I want to end the arc here. And I wanna click here because I want the top of the arc to be touching this line. As you can see, the arc is not fully defined because there could be other ways to draw this angle, draw this arc. So what we're going to do is to define this. Like, we're gonna select this arc, we're gonna select shift this line, and we will tell SolidWorks that we want them to be tangent. Okay? And then we will do the same with this side. We'll select this arc, then this side, and then tangent. And now we have fully defined arc because this point is tangent, this point is tangent, and it's touching this, so it's basically like a semicircle. So there couldn't be another way to draw it. So we're gonna build the other side. We create an arc here, we create an arc here, and the top of the arc here. So right now it's not fully defined. We click here, tangent again, then we click here, and we click tangent again. And okay, now we have fully defined button. So since we have two buttons here, And to make things easier, we can just copy and paste here. To do this, we're going to use a function called linear sketch pattern. So to start, we need to select all the lines that we want to copy. So let's select them. I'm going to select this line. I'm going to select this one, this one. I'm holding shift right now. And this one. Okay. Now that I have selected all the lines that I want to copy, I click linear sketch pattern. And as you can see, it wants me to copy this part to this side because I have these parameters. The parameters are x-axis, this axis, 10 millimeters away from this point. We're creating two shapes and also displaying the direction, which is 0 degrees. This is 0 degrees, this is 90 degrees, this is 180 degrees. So since we want the other button to be from this side, we need to select 180 degrees. So it goes this way, and we tell OK. Tell it OK. So now we have this button. So to fully define this, we need to first select this point and this point, and select horizontal. And we also need to specify how far they will be, and we will select 16. Okay. Now we have fully defined a drawing right now, and we will move to the third dimension. We will extrude this drawing to create the part of our controller. So to do this, as the video before, we go to features and then extruded boss base. And since it's a more complex drawing, we need to tell SolidWorks which shapes we want to extrude. In this case, we don't want to extrude this part of the control because we are making like the structure of it. So we're going to select this part. We're going to select also this part, and you need to take a lot of care to select all the tiny ones because, as you can see, SolidWorks has not selected these tiny parts between the arc and our rectangle, and we need to select it. Be very careful to select all the parts. This, even this part that is very small. Okay, also this part too. Need to be very, very careful because not that you will have some mistakes, so please take care of it. Okay, you need to select this part. You're gonna select this part, and this part. So it appears we have selected all, and we want it to be extrude 10 millimeters. Okay, so we click OK. Okay. So we now have an extrusion of the drawing we made. So since this part we're making is just like the upper part of our structure of the controller, we want it to be empty at one side to be able to fit all the electronics. So considering we're using the control like this, the insides of the controller will be this side of the 3D model. So right now we're gonna use the shell tool. I'm gonna select this face. You see, this arrow is at the right side, so this is the inner part of our controller, and we're gonna select shell here. Now that we have selected shell, we need to put 1 millimeter here. You'll see why. We'll put OK. And as you can see, it created a shell of our shape. And the walls here, the border walls, are 1 millimeter thick. Now, the problem here is that these walls are too big. The border walls from this controller, they are okay, but these walls from inside the controller, they are too big, and we will not be able to put the electronics inside. So we need a way to cut them a little bit, to change from 10 millimeters to 2 millimeters of height. So one way to do it is to click at this plane and then click sketch. As the last time, we are creating a sketch in this plane at the border, at the borders of this wall. So right now we're gonna select corner rectangle, and we will try to build a rectangle that is surrounding all these center parts. So it will be around here. Something left there. As you can see, it's underdefined. We need to define it. So let's start. So first things first, I'm gonna say, okay, this side should be away from this side around, let's say, 9 millimeters. Then this side and the origin should be maybe 15 millimeters away. And now we're gonna define what should be the size of this. I'm gonna tell, okay, I'm gonna be 118 units, and this side will be around maybe 40 units. Okay, now our rectangle is fully defined, but we're not surrounding all the, oh no, maybe yes, could be. Yes, we're surrounding all, I think. Yes, we're surrounding all the parts here. Be careful, because if your rectangle it's at the border, when you cut, you will cut also this border, and we don't want to cut this border. We want just to cut all this inside. So right now it's just verified that it's fine right now, and yeah, it's totally fine. From this side and from this side, it's okay. So now that you've built your rectangle that is fully defined, then you go to features, and then you go to extrude cut, and you put 8 millimeters because it was initially 10, and so we click 8 millimeters. As you can see, now the balls are much more smaller, 2 millimeters, and the border are still at 10 millimeters. So this is all for this class, guys. Please save this file. Go to save, file, save, put the name as you like, because we're using this drawing and this 3D model for the next classes. Okay, so thank you and goodbye.